Hi everyone. At the instant shown in the figure, the 50 kilogram block at A, so this is 50 kilogram, is moving down the plane at 2 meter per second. So the velocity is just 2 meter per second and is attached to another block on B. The weight of block B is 30 kilograms. We got a coefficient of kinetic friction between the block of it's just mu car is equal to 0.2. We want to find out the distance block A slides before it stops. So it has to slide for just the distance and then it just stops. Let's start the things with a free body diagram. If we assume that this is slide A, so there is a tension uh, that is MA because the box is just moving downward. Um, what else do we have? We have the mass of the box mg, and we have the normal forces which is perpendicular to that. So the box is sliding down, yeah. The friction force is just acting on here to just act as an obstacle to the box, not stop it moving. That is for A. So easy we can find out that the normal forces or N is equal to mg, and then we don't forget this one. Actually, this is a right angle triangle with 3 4 5. N is equal to mg times 4 and 5, or if you got the angle, so you can just sub in the angle. So we got V naught is equal to 2 meter per second. There is only one tension linked to the box here. The tension is equal to the, what is that, plus the force of friction, which is mu car n minus mg 3 on 5, this is it, and then minus ma, are all equal to 0. So that is mg, which is coming down, so it is in the negative direction, and ma again is in negative direction. The same will be drawn for block B. So block B is just, I guess it's just much easier because we got only one tension and the forces of the mass. So tension at B is equal to mass of B minus mass of B, the acceleration, and that was the gravitational force. We know that tension at A is equal to tension at B, and it is just by visualizing we can find that. There are a lot of other ways to just consider that, like how we did in the contact classes. Just gonna tell you that if you look it up by visualization, you will find that length of A. I'm just gonna draw something and then I will clear them out. Length of A is equal to the position of A, whatever this position is, plus 2 times of this whole value, 2 times of SC. We know that the length of B is equal to this value, which is position of D, and then we have this little one, which is plus SD minus S of B. So you know SC plus SD is the whole length. And we know that the acceleration at A again must be equal to acceleration at B. These are something that we can just easily find them by visualizing. So now what I'm gonna do is that I will need to equate the tensions with one another to just find the acceleration. So I just slide the page over a bit. So I'm just gonna write down uh, the whole things um, plus this whole value plus this value. So this value plus this value should be equal to 0, and then from these two I will find out the acceleration. I'm telling you what am I doing, so because I'm sliding the page up a bit. So the forces of friction, which is mu car mg times 4 and 5, that's what we got them here. That's what we got them here. Minus m of a g times 3 and 5 minus ma aa plus mass of b gravitational force minus mass of b acceleration of a is equal to 0. So I will get m mass of a, mass of a. So I will just rearrange them. I will get ma plus mass plus mb times, oops, times the acceleration. We know that the acceleration a and b are just the same, is equal to m mass of b acceleration gravitation plus mu car mg times 4 on 5, which is this is for block of A minus 3 on 5, again mass of block A g. So we know that this is one of them is 50, one of them is 30, 30 plus 50 is 80. So if what I do, if I just divide the whole value by 80, I will get acceleration by itself. So that's what I'm doing now. So I would say A is equal to mass of B is 30 times 9.81 plus mu is 0.2, 9.81. Then we got 4 on 5 minus 3 on 5. Mass of A again is like 50. All right, yeah. And then that's time 9.81, and everything is divided by 80. So if you just sub in the values to your calculator, you will get 0.981 meter per second squared for the acceleration of the whole thing. Then from here, it's just pretty much easy. We need to work with the kinematic expressions or formulas. You know that S is equal to S naught plus V naught T plus half A T squared. Um, we know that the velocity is just taken from V naught plus acceleration times time. If I just rearrange this formula, I will get T by itself. So T is equal to V minus V naught over A. If I just sub this one into this formula, I would get S is equal to S naught plus v naught. Instead of t, I would put this value, which is v minus v naught over a plus half a. Again, instead of t, I would put v minus v naught. I would put here squared over a squared. So just a bit of cancellation. This a will go with one of these a, and then if I times both sides of the equation by 2a, what I get, and I just get this s to the other side, I would get 2a times s minus s naught is equal to, I've got v naught uh, v minus v naught over a, which, as I said, I will times them by 2a, so I would say 2a times this whole value, v minus v naught, plus so this is, if I just again sum in by 2a, I would cancel both a's and this will go on, so I will get here v minus v naught over 2, which is an identity. This one is the first one squared, v squared, plus the second one squared, v naught squared, plus 2 times v times v naught, which is minus 2 v naught. And this is another one. So just let me expand that out again. I would get 2a s minus s naught is equal to 2a v naught v minus 2a v naught squared plus v squared plus v naught squared minus 2 v naught. I guess sorry, that is cancelled out. I made a mistake here. That has gone, that has gone. So here I just have 2v naught v, and these two will cancel out. So from here I will only get 2a s minus s naught is equal to v squared minus v naught squared. You know that, again, that is by formula. You have had it already. So s is equal to 1 over 2a v squared minus v naught squared plus s0. If I just sub in the value, I get for acceleration is 2, acceleration is 0.981, v naught is 0, because it just finally comes to a stop, minus initial speed was 2, which is 4. Sorry, I guess it was 4 meter per second or 2 meter per second. I guess it was, yeah, 2 meter. 2 plus 0. From here, you will get the, it will move for 20.4 meter before it comes to a halt.